Okay, so what did we learn in our lab? So this is the equation of what's happening in our lab. We had vinegar and ammonia, and they mix together. The indicator dye just told you if it was an acid or turned into an acid or a base, so you could see which way the reaction was going. And when you mix those two together, you get some heat off. So heat or energy is like one of the products. So you have your reactants turning into your products. And remember, this arrow can go either way because it can go backwards or forwards. So when we put it in, Le Chatelier's principle says that when you stress a system, the system will shift so that the stress is relieved. So what you kind of have is your reaction going like this, and if I put, here's your reactants turning into your products. If I put more products into the system, in fact, like I'm adding a stress to this side, what happens is it forces the reaction this way and it ends up making more reactants. But if I'm back at equilibrium and then I add a stress to this side of the reaction, I add more this way, it forces the reaction to go that way to make more products. So in this reaction, heat is one of my products. So if I put this reaction into heat, that means I'm stressing it on this side of the reaction. So I'm in effect, I'm kind of adding pressure to the products. So it forces the reaction into this way and it ends up making more reactants. So that's why when I added it into the hot water, my reaction would go this way and it would turn blue, or ours was kind of purpley blue. But when I added it into the cold temperature, that meant that I'm adding more pressure to this side of the equation, forcing it that way to make more heat. So I'm forcing the reaction to go this way, and then my reaction turned green because I was forcing it to make more products, to make more energy, more heat, because I used up the heat in the cold temperature. So in cold, I added a stress to this side of the equation, forcing it that way. In heat, I added a stress to this side of the equation and forced it this way. And that showed you the change in color. So make sure you write up a lab in that for that reaction. Also, you can get used to seeing some graphs like this. So we did this kind of graph before where you have your forward and your reverse reaction going and reaching equilibrium. So this here would be a stress then that you add to the equation. So again, this in our lab, it was adding heat or removing heat. That was the stress to your equation. But here, this one, you're adding some sort of stress here, which means your reaction will then shift to either make more products or reactants, but it will again come to another equilibrium. So your equilibrium will be different, but it will again come to an equilibrium. But Le Chatelier's principle will allow you to take into account a stress on your equation. Okay?